Okay, revision first. Wave. Okay. Wave. We have water wave, and then right. Okay, this one you have seen it before. This one, the red arrow is also a wave. This one, sound wave. We will mention it later. We have the other chapter, chapter 18. Is it okay? Will be about the wave, sound wave. The other one, light wave. One of the chapter will mention this. But actually, what the wave actually will be the vibration. Okay, the vibration. For example, for the water wave, will be the vibration of the water molecule on the surface. Will be like that. This one, okay, this one. This one actually is the side cross-section area. Okay, the cross-section view of the wave. You can see that the wave, the water surface of it will be up, somewhere will be down, like that. And this one will be the experiment. You haven't any chance to read in it in Physics Net, but when we have the face-to-face teaching, then you can see this one, okay? And this one will be the animation for it, okay? But of course, this one is the stop motion. Initially, will be this case, okay? This one, usually we will say that 0 second. And then this one, we will call it vibrator. This vibrator will move up, then it will make the string like that. And then next time we'll move down to the original position. Can you see it? This one is the original position. This one is the original position. Then you can see that this part of the string will move like that. And then this vibrator will move down further downward direction like that, and then go up. Finally, what will happen? You can see that this vibrator is up, down, and then up. Finally, this one will be the same position. Okay, it means that this one, same position. In this case, we will say that we can produce one vibration. After one vibration, how about the shape of the string will be like this? Okay, then we can say that we can produce one wave pulse 脈衝，得唔得 ？Vibrator move up down up 就會出到一個 wave， 我哋會叫做 pulse。Okay, and also you can see that this one will be the initial position. Initial point, this point, this point, and this point. You can see that the wave is produced. One water wave pulse produced. Then how about this part? It means that this part will not have any disturbance. This one. DISTURBANCE 騷擾 disturbance. You can see that here all the part will not be disturbed. Okay, if we have only one water wave, but after the time is going, then we will have the second pulse. Actually, this one is not second. This one should be the first pulse. But this vibrator can make the other wave pulse. Then this one we will call it second. And then third and so on. Then this disturbance will affect the whole string. Afterward, we can say that the water wave or the wave is propagating. 傳輸緊。Okay. Then you can see it. Look at this one. Your hand will be the vibrator to vibrate the particle on the string. You like that, this one. But what is going on here? You can see that, especially in chemistry, you should know that this one is a molecule, the other one will be the other molecule. Between it, we have a bonding in chemistry. And for physics, we will say that we have the attractive force between it. Okay, then they will affect each other to make up the water wave or the wave propagate on it. This one will be the Yan long, okay, mechanical wave produced by the human being. Exactly the same. Then you can see that each particle repeats the motion of its neighbor. 隔離點喐，佢會跟住喐，但係唔係一齊同時間嘅，會有 delay 嘅，爭少少。So you can see that the pattern shift forward. Forward means that the propagation direction of the wave. 你見到個 wave 向呢邊行咧，向呢邊行咧，咁就係個 pattern 就 shift 去 forward 啦。呢個就叫 forward direction. And then here we also have the other name for them, the terms. The first one, full wave. It means that we have up, we have down. Okay, then this one we will say that full wave. How about the other one, half wave? Only the up, only the down. Okay, if we produce the wave not continuously, maybe here, sometimes we have the pulse, sometimes haven't, sometimes we have. Then this one we will call it pulses. But if can produce this pulse continuously, then we will say that train of wave. This one. Remember this term, periodic 周期性. What does that mean? It means that the wave can repeat itself. Itself means that the pattern can repeat the same pattern many times. Then we will say that periodic. Okay? And finally, the pattern of it, we will say that wave pattern. The key terms, we will say that waveform. So look at this. If I can produce the pulse like that, if the wave or the vibrator can produce the same pattern like that, okay, link up together, it means that you can repeat it. Then this one we will call it a train of wave. And here, how many pulse here? We can say that 2. But why? Because these 2 have the same pattern. Okay? And other than the water wave, we have the mechanical wave. It means that we will have the medium. It means that the particle, and particle. Here we have particles. Link up them together. This one move out. This one will move out, but not the same time. Okay. And the other one will be the EM wave, electromagnetical wave. This one without any medium, mediumless. For example, vacuum. The most common example will be the light wave, will be one of the EM wave. How about this? Here, we have 2 different types of wave. The first one, we will say that traveling wave. It means that you can see the wave pattern can move. Okay, so look at this. The waveform shift forward or backward, of course. If you say that this one is the forward direction, then the other direction, the opposite direction, we will call it backward. If you can see the waveform can move, then we will say that this wave is traveling wave. On the other hand, if you can see that the wave cannot move, fixed here, can you see it, this one? You can see that something concentrate here. But how about this point? Nothing. Then you can see that this part seems to be stay here. Then we will call it stationary. 中文叫做駐波，駐即係駐守個駐啊，即係企咗喺度咁解。Okay, here waveform appears to stay. Here very important word appears. 睇落好似唔喐，其實佢喐緊。不過唔係個 wave 喐緊，係啲 particle 喐緊。咁但係個原因點解咧？遲啲學。OK， 咁我哋學咗 traveling wave 先嘅。Okay, so here starting from the traveling wave instead of the stationary wave. Actually, what is the meaning of wave? Is energy, the energy transfer. So here, wave carry energy. For example, the most common example will be the sun. The sun using the fusion, nuclear fusion, 用核聚變 to produce light wave. This light can travel through the vacuum and then go to the earth. Okay, so for our human being living in the earth, we can have energy coming from the sun. This energy, we will call it light energy. Okay, light is wave. So wave can carry energy. Okay, transmit energy from one place to the other place. Exactly, when you look at this photo, you can see that this fingertip tap on the water surface can produce water wave. This water wave can disturb, okay, this leaf on the water surface, but not immediately. Wait a while because the wave should need time to travel from here to here. Finally, you can see that this leaf will move up and down. It means that it gains energy. Okay, this one explains that wave. Okay, what's wave? Energy transfer. Okay, from one place to the other place. Wave 波波係咩意思咧？傳遞能量嘅方法。Okay, so look at this wave. Okay, transmit energy. Of course, vibration is one of the type of energy, but not matter. Sometimes we will use the matter to help us to transfer energy, but we will not transfer matter. 我哋唔可以搬啲 particle， 我哋只可以震嗰啲 particle。所以咧，當你做人浪嘅時候，啲人咧只係喺度震嘅啫。咁你唔會見到啲人咧就隨住個波浪咧而travel 嘅，即係由一笪地方去到另一笪地方。咁啊做唔到嘅。Okay, so next one. In practice, a wave shakes generally as its energy is lost. This one, what is the meaning? This one tells us that energy transfer from one place to the other place, we will have energy loss. But how to know that the energy is lost? You can see that this part originally should be too high, but after a while, certain distance, this one will be lower and lower. This part, what we will call, in the coming part, we will mention it amplitude. In the last lesson, we also focus on this word. Okay, but up to now, it's a revision. Okay, afterward, I will mention it again. So you can see that if the amplitude is decreasing, it means that the energy is decreasing. This one, despite shaking, a wave travels at a constant speed. This one very, very important concept. Someone will think that if the energy is reducing, okay, is losing, then the speed of it should be lower. Once again, tell you, wrong. Okay, the most common example of it should be light wave. Do you know that what is the speed of light? Okay, I think some of you should know it. Should be c, speed of light. Can you make the light energy smaller? Of course, yes. We can use the sun gas to reduce the light intensity. But at the same time, can you reduce the speed of light? Of course not. Okay, the speed of the light will keep the same, should be C. What is C? Should be 3 times 10 to the power 8 meter per second. Very, very fast. Okay, so once again, this one, the Ch13 just only reduce the energy, but we cannot change the speed of the lights. Okay, so next one, you cannot make a wave travel faster by shaking the string more rapidly or wirelessly. 我哋揈快啲，所謂揈快啲，只係改變佢嗰個嘅高度，或者改變呢度嘅密度，但係其實你係唔可以改變速度。即係我唔可以咧將個燈膽整光啲，啲光就行得快啲嘅，唔得。OK， 記住。So next one, kinds of wave. Inside the wave, especially the traveling wave, we have two different kinds. They are transverse. Okay, transverse wave. What is the transverse wave? I showed you already, up and down. The particle will be vibrated due to the vibrator here, moving up and down. Then this one will disturb the other one. Okay, and then we'll have the other motion, but not at the same time. So you can see that they will have different displacement. Like this, for the oscillator or the vibrator, can move the water surface up and down. And this one we will call it transverse wave. And when you make the water wave up and down, then you can see that somewhere will be down, somewhere will be up. Finally, the shape of it will be like this. Then this one we will say that transverse wave. You can see that this diagram already, okay? Exactly the same. Here, I want to show you the animation. Then look at it, what will happen.
We can use a slinky spring to observe the properties of transverse pulses and waves. Stretch out the slinky spring.
Hi, okay. Share the screen as a while. Okay, share window. This one.
We can use a slinky spring to observe the properties of transverse pulses and waves. Stretch out the slinky spring. Attach a piece of plasticine to it. Shake one end of the slinky spring to produce a transverse pulse. Note how the coils of the slinky spring move when the pulse passes.
Now, of course, when you look at this video, okay, the performance is not very well due to the e-meeting. Okay, so, you can see that the video file is not smooth enough. But never mind, when you go back to the school, I will do this experiment to you. Okay, keep going. Okay, wait a while. Okay, go back to here, the terms. We have mentioned these terms already before your summer vacation. The highest position, we will call it crest. The lower position, well, we will call it trough. 中文叫做波谷，呢個叫做波峰，山峰嘅峰。Okay, so this particle can move up and down only. Move to the highest position, we will call it crest. Move it to the lowest position, we will call it trough. But once again, how to measure the position? We will use it as displacement. Up, we will call it positive. Down, we will call it negative. Okay, so this one exactly the same as the concept in mechanics. Okay, next. The other type of the wave, we will call it longitudinal wave. 環波，環嘅，即係打橫。So look at this. Oscillation along wave traveling direction. If this one is the traveling direction, it means that your vibration should not be up and down, should be left and right. Okay? Move forward and move backward to disturb your neighbor particles. Then they will gain energy, and then this energy will be transferred to next neighbor particles. Then we can produce longitudinal wave. The case will be like this. Okay, you can see it from the screen. You can see it. The red one, forward, backward. The blue one, also moving forward and backward. But here, this two, they are not moving in the same time. Okay, when this one go to here, the blue one will go to here. They are not moving in the same time. Okay, but what can you see? You can see that the red particle and the blue particle will move forward and backward. How about the wave? You can see that the wave is traveled from here to here. They are parallel to each other. If they are parallel, we will say that this wave is longitudinal wave. 縱波 and 環波 ，OK？ 縱波咧就係 up and down， 個 wave 打橫行 ，perpendicular，OK？ But for longitudinal wave 環波 they will parallel to each other. How about the sound wave? I say that we will mention it later in the later chapter. Sound wave is the most common example for longitudinal wave. Okay, how to know that? Because we can see that when you hit this material, this one 音叉, then it will produce the vibration, move forward and backward to disturb the air particle around it. So the air particle will move forward and backward to disturb the other air particle. Finally, disturb your ear. Okay, ear diaphragm, 耳膜. Then you can hear the sound. So sound wave is the most common example for longitudinal wave. The oscillation will be oscillating in forward and backward direction. Like that. Okay. This one, of course, this experiment I will show you later in face-to-face lesson. Here we also have the terms reaffection and compression. How to distinguish it? Very easy. But how? You can see that when you move it at a certain position, you can see that they will close pack together. Then we will say that compression. For example, here you can see that you can't see anything. Okay, the wire and wire, the separation between them is very large separation. Then this one we will call it reaffection. Okay, once again you can see that we have compression, symbol is C. Reaffection, the symbol will be R. Then you can see that this one is the repeated pattern. 嗱，最緊要 wave 嗰課裏邊係要學識啲 pattern 個樣啊， 個樣似唔似？似嘅話就代表一個 pulse， 得唔得？咁所以你見到 C 與 C 之間咧，其實係一個 pulse， 係咪啊？好 ，Chapter 1 we have done it already. Chapter 1 should be on your page. Wait a while. I open my book. Should be page 12. Revision. Okay, remember it. This lesson is about the lesson before your summer vacation. Okay, but never mind. Long time ago. So this one is a revision. Look at this. Transverse wave. Once again, what is the transverse wave? Means that move up and down, and then the wave will propagate in this direction. They are perpendicular to each other. Now, this one. Say that we will have a medium for this wave to travel. The particle moves in the same direction that the wave travels. Yes or no? Okay, you need not to answer me because this one I have done it already. But in your mind, you should know that the answer should be wrong. Okay, for the transverse wave should be this diagram, up and down, perpendicular to the traveling wave direction. Okay, so this one is wrong. How about second one? Longitude wave. It means that move forward and backward. Traveling direction should be parallel to each other. Then this one we will call it crest and trough. 波峰波谷. Alright, this one seems to be this. Transverse wave, not longitude wave. So this one is wrong. Okay, for this, okay, the longitude wave, you should say that this one should be compression, rarefaction, and compression. Should be like this. Okay, part C. We can hear a bird singing. It means that this one should be related to sound wave. Because air molecules are transferred from the bird to you. Once again, this one is wrong. If the bird, it means that the air particle near the mouth of the bird, all of them go to your ear, then you will feel wind. 呢個風咧係空氣粒子嘅流動 ，exactly the same as this, but this one is not singing. Okay, so this one is wrong. What is the solution? Suggested solution will be this. Okay, energy is transferred from the bird to you, carried by sound wave, not the air particles. Air particles just only have the vibration between particles. For this vibration, we can transmit energy to your ear. Okay, second question. Say one difference between transverse and longitude wave. Okay, of course, will be the vibration direction. One of it is up and down, the other one is forward and backward. But how to mention this relationship? The key terms will be perpendicular and also along or parallel. Okay, I mentioned it already. All of them should be referred to the wave direction of travel. Okay, question number 3. Jimmy is still north from you. So write the coordinate. This one is you. North should be up. Still north from you. So Jimmy should be here. Now, when he shouts to you, it means that produce sound wave to you. Then air particle oscillate what? As the sound passes. You should show the exact direction. Because this one is the sound wave, it means that the sound should be the particles should move forward and backward. But how about here? Because we have the direction, I think the coordinate system for it. How to say that forward and backward? You should mention the direction of it using the south-north and east-west like this. So answer should be B. But how to know that? Because this one refer to you should be north. Okay, Jimmy position should be north. Then this one we will call it backward direction. Yeah, but Other than the backward, we have the forward. Should be opposite to the north direction. Opposite to it should be south. Then it means that the particle should move along north-south direction or south-north direction. Final answer should be option B. That's all. Okay. Keep going. Terms for wave. Here, I have mentioned that in the previous lesson, we focus on these terms. Amplitude, 幅度. It means that refer to the original position. This one we will call it equilibrium position. Then move up, we will say that positive. Move down, we will say that negative. For the here, time for one cycle, we will say that period, 周期. How about this? Within 1 second, how many cycles can produce? We will say that frequency, 頻率. Okay? 1秒可以產生幾多個 wave？ 咁呢樣嘢叫做頻率。Okay? Now, very important part, especially for chapter 13, focus on the terms for the wave. Remember it, this one we can say that equilibrium position. In physics, mechanics, this point we will say that zero displacement. Move up, we will call it positive displacement. Move down, we will say that negative displacement. How about A? A will focus on the maximum displacement, the gap positive and negative side. For example, if A is 5 cm, then we will say that amplitude is 5 cm. The displacement can be positive 5 cm and also can be negative 5 cm. This show will be the displacement. But if the question focus on A, amplitude, your answer should not have any sign, just only 5 cm. Okay? But in this case, A1 and A2 may not be the same because the waveform of it is irregular. Okay? You should choose the maximum one. Here, maximum displacement should be the maximum one. In this case, should be A1, should be maximum one. But how about the displacement for the longitudinal wave? Is it difficult to measure it? Actually, yes. So in DSE, usually for the wave, 10 questions, 9 out of 10 questions will be traveling wave. And traveling wave with transverse wave. Because this should be the most common example in wave. 10題有9條係 traveling transverse wave， 最多得一條係咩咧 ？longitudinal wave， 即係呢隻。咁因為複雜難睇 ，OK？ But how to observe it? You should focus on one of the particle, and then measure the maximum displacement and minimum displacement. The middle one will be the equilibrium position. Okay. Next will be the next term. But before I start this term, go back to here. We know that 3 of them: period, amplitude, and frequency. We will mention it later. Okay, what is the meaning of wavelength? Coming from this word, you should know that length of a wave. So you can see that equilibrium, highest position, crest, lower position, trough, and then go back to equilibrium position. Then you can see that this one is one pattern, and this one can repeat the same pattern 2 times. Okay, then you can see that, oh, this one is one cycle, 一個循環. Now you can measure the length of this cycle, and this one we will call it wavelength. But this one is a Greek letter, 希臘字母. This one we will say that lambda. 寫法咧就係成個入字咁嘅，呢個叫 lambda. 但係呢個咧電腦出嘅咧已經唔係啱嘅，正式希臘字母咧個 lambda 係咁寫嘅，成個長頸恐龍咁嘅，得唔得？不過因為書本上邊出唔到咁嘅字，因為如果出到咁嘅字，寫幾個字咧，你成版咧就已經係得個 lambda 個字嘅啫。咁所以啦，我哋嘅印刷版咧就規限咗佢一個長方形咁多嘅啫。OK， 咁記住讀音叫做 lambda， 唔好講係入字咁 cheap 啊嚇 lambda。Okay, here the shortest distance in which the wave repeat itself. Okay, it means that the pattern will repeat and repeat. But you should try to find out the shortest distance for it. But why? Look at this. If the pattern like this, you can say that starting from here to here will be exactly the same as this. You see? Yes, of course. You see? Okay? Exactly the same as this. But now, you can see that other than it, we can break it down like this. You also can see that this part, and this part repeat itself. Can you reduce the distance between it? Finally, no. Then we will say that this one should be the shortest distance. If like that, then we will call it this one is the wavelength. So, in summary, how to measure the lambda? Here, wavelength. For the transverse wave, you can measure crest, trough, crest. Okay, the pattern will be like that. Then we can see that crest and crest, the distance between them, we will say that lambda. Or trough. For this distance, we also can say that lambda. So in English, we will call it successive. 連續嘅，連續兩個 C 中間嘅距離就會叫做 lambda 啦。So in this example, you can see that 5 repeated patterns. So each one, the length of it, we will say that wavelength. Okay. How about the longitudinal wave? Similarly, but not exact. Okay. In this case, you should try to find out the C, the compression center. Now, all of you, because this one is moving, focus on the C. Where is C? I draw it here. C will be 5 of them concentrate on each other. But here we have 5. Which one is C? Should be the middle one, C. On the other position, we also can see that 5 of them concentrate to each other. Then the middle one, we will call it C. If like that, the distance between C and C, we will say that lambda. Do you understand? So other than C and C, we can have arrow and arrow. The distance between it, also lambda. Okay. Okay, last two. Period and frequency. What is the period? In order to produce or vibrate one cycle, the time for one cycle will be period, 周期. The most common example will be 1 week. No, not 1 week, 1 month. 1 month. This one actually will be the orbit of the moon, rotate about the Earth 1 time. Then this one we will call it cycle. The time for it is about 28 point something day, 28日 ，OK 至30日到啦嚇。咁有個周期嘅，呢個就係要做一個循環所需嘅時間。We will say that period 周期。So here, you can see that this one, starting from here, equilibrium position, and then go up, and then go back to equilibrium position, lowest point, go back to the equilibrium position. Okay, if like that, this one we will say that one complete wave or one complete cycle. The time for it, we will say that one period. Okay? So if I say that the period is 1 second, then you can tell me that this one. This one, I say that is 0 second. Then this one will be 1 second. This one is 0.5 second. This one will be 0.25 second. 0.75 second. Like that. Okay? Usually in your exercise, usually we will say that this time t is 0, of course. This t, instead of the numerical value, we will say that a quarter of period, 4分一個 cycle. This one we will say that 2 quarters. 嗱，呢個唔係2有4分一，係2個4分一，咁即係2分一。This one should be 3 quarters. And lastly, this one should be 4 quarters. It means that 1 t. Do you understand? 嗱，記住 period 係時間嚟嘅，記住 period 係時間嚟嘅。On the other way, this one. How about 1 second? Within 1 second, how many cycle or how many vibration that you can produce? Okay, if like that, the unit should be per second. This one should be number of cycle. Okay, 所以個 unit 唔係 second 啊，呢個 per second 嚟嘅 unit. Okay, for example here, frequency 頻率 per second is 2.5 cycle. How about 1 second? What will happen? Go back to here. 每1秒鐘產生到 2.5 個 cycle. 咁1秒即係產生幾多啊？ 2.5 個 cycle. Is it true? Starting from this one, 0, 1, 2, 2.5. Okay, so here we can have 2.5 complete wave or complete cycle. 得唔得？ Now we want to find out the relationship between period and frequency. 1秒鐘1個 cycle. 所以1個 cycle 1秒鐘 1 hertz. But how about this? If we have 2 hertz, what's the meaning of 2 hertz? 2 cycles per second. 2 cycles per second. It means that 1 cycle you need to have 0.5 seconds. Then this one we will say that 1 period. 所以記住 frequency 越高 period 就越低，因為呢個 relation 唔使背，考試俾埋你，得唔得 ？OK， 好 ，next one。Chapter 2。嗱，我記得 Chapter 2咧都好似講咗嘅嚇，得唔得？咁啊，如果我有啲嘢係未講，我以為係 revision 嘅話咧，就唔該提我啊，喺個 chat room 度。OK， 好嚟啦。What are the following properties of the wave called? Transverse wave. It is equal to the displacement of the particle at the crest in magnitude. 其實佢問你以下嘅嘢係關於 displacement of a particle at the crest 嘅時候，佢叫咩名？得唔得？咁當然叫做 amplitude 啦，幅度啊嘛。點解啊？因為個 particle 去到最高點，咁即係 maximum displacement， 咁嗰度咪叫做 amplitude 咯。咁但係記住啦，唔好分正負嘅嚇。Okay, second one. For transverse wave, it means that up and down, perpendicular like that. It is equal to the distance between two successive troughs. 喺個 transverse wave 裏邊，兩個 trough 之間嘅距離叫咩名啊？應該識啦，嗬。 嗱，因為呢個 relation 啦，我唔需要大家答啦，遲啲再答其他問題。Wavelength， OK， part C. For longitudinal wave, it is equal to the distance between two successive compression. C 同 C 之間嘅距離叫咩名啊？都係 wavelength。Part D. Minimum distance for a wave to repeat itself. Wavelength。哇！死啦 ！wavelength 咁多 definition 嘅，係啊，因為我哋有唔同嘅 wave 啦。OK。好，E. It is the number of wave produced in 1 second。嗱，小心啲啦，1秒裏邊有幾多個 wave， 即係1秒裏邊有幾多個 cycle， 呢個叫做頻率，英文叫做 frequency。OK。It is the time required to produce one complete wave。要產生一個 wave 需要嘅時間叫做周期 period。Okay, second question. If the question gives you this value, within 1 minute, the vibration is this time 39,600 times. What is the frequency? Before you answer me, go back to here. What is the meaning of it? Vibrate number of times in certain time. So if we can make it like this, because in your mind, you should know that all the time should not be 1 minute, should be 1 second. Then it means that you should use this value over 60. Then you can see that we have this times, number of times per 1 second. This one should be the definition of the frequency. So your answer should not be this because you should over 60. Okay, final answer, option boy. You understand? Okay. What is the unit of the frequency? Should be hertz. 呢個 hertz 就係頻率嘅單位啦。Okay. Okay. Question number 3. Totally, we have 4 questions in this chapter. This one will also be the third level 中學會考關於 wave 嘅第一 part A part 嘅問題，唔識作得㗎啦。Okay. What is the amplitude of the wave? Look at this. You should find out where is the equilibrium position. Should be here. Then we can say that the displacement here should be 0. Now try to find out the crest. The maximum displacement should be here. And then ask yourself, what is the meaning of this? 5 grips should be 5 cm. It means that 1 grip will be 1 cm. Here, totally, we have 7 grips. So your answer here, amplitude, should be 7 cm. Next part, what is the wavelength? Try to find out here the number of repeated pattern. We'll have 2, 1, and 2. So this part, we will say that lambda, wavelength. How many? 1 grip, big grip, should be 5 cm. Here, we have 4 big grips. Answer should be 20 cm. That's all. Remember it. This one is part A question. In the coming assessment, we also test you like this. Okay, part A. Any question? Okay, last question. Peter push and pull. 擺到明推又拉 longitudinal wave because this one should be forward and backward direction. Now, within 2 seconds, we have 4. Pay attention on this 4. 公開考試極賤格嘅，佢唔會寫數字，數字容易睇啊嘛，佢會寫英文，等你難睇啲。但係記住 ，4 wave in 2 seconds 咩嚟㗎？咪話緊俾你聽 frequency 咯。2個 wave 2秒，咁1個 wave 幾多秒啊？咪1個 wave 咪1秒鐘有幾個 wave 啊？2個咯。咁所以啦，佢嘅 frequency 應該2個 hertz 嚟。Okay, now here 4 successive compression is 90 cm。嗱，呢個超賤格，小學最難嘅數學問題，數樹問題。而家有4棵樹，佢哋相距90 cm。 記住唔係除4，係除3，得唔得？而家有4個 compression， 我哋識得 compression 與 compression 之間叫做 wavelength。而家呢個90 cm 唔係4個 wavelength， 只係得3個 wavelength。呢個就係賤格。不過 short level 都係 part A 問題，你要識睇，死咗死得㗎啦。Okay? So here I told you everything already. Wavelength, frequency, and period。睇啦嚇 ，wavelength 90除3啱啱 up 咗 ，frequency 4除2即係2啦。period 係咩啊？要完成一個 cycle 所需嘅時間，咪數手指咯。我4個就2秒，咁我1個咁咪0.5秒咯，得唔得啊？你發好淺嘅，因為拍戲。OK， 嗱，revision 咧差唔多完㗎啦，就準備新嘢。OK， the new thing will be wave speed。OK， I have mentioned that wave is a method to transfer energy, but we need time. For example, the light from the sun will have time to travel from the sun to the earth. Okay, in terms of minute. 佢以分鐘去飛嘅嚇，唔係以秒啊或者年去飛嘅嚇。So look at this. The distance traveled by a train of wave. Okay, per unit time. 我哋要睇一個 wave 每一段時間行幾遠，咁嗰個咪 speed 咯。So this one very easy. Focus on the mechanics, the initial part. What's the meaning of speed? Should be distance over time. Okay. Then how about what's the distance? Because we know that the concept is this. For one pulse to be produced, this one is the repeated pattern. This repeated pattern, the shortest distance for it, we will say that lambda. Then if we think that this wave will travel this lambda distance, okay, distance will be lambda. The time for it to produce like this, what's the time? Should be the time for produce one cycle. By definition, this one should be the period T. That's all. Using the mechanics, we can have this definition for the wave speed. The wave speed should be lambda over period. But what's the 1 over period? Should be the frequency. Finally, we can get this formula. This formula, we will say that V is equal to F lambda. 速度係等於 frequency 乘 wavelength。呢個 formula 叫做 wave equation。成本書用呢條嘅啫，幾時都會用。OK， 得唔得？記咗佢，不過公開考試俾埋你。不過你用得多，計埋數，你就唔使睇㗎啦。雖然俾咗你。So look at this. 0 time, no distance. Okay, but how about this? I give it a quarter of period. 咁佢咪做1/4個 cycle 俾你睇咯。咁既然佢做得1/4個 cycle 啦，佢行就只係行得1/4個 cycle。咁所以啦，佢行嘅距離就1/4個 lambda。所以跟住你發覺兩個去搞下之後咧，其實係相同嘅速度嚟嘅。咁每時每刻都係相同嘅速度，得唔得？咁所以啦，最緊要你識望最後尾嗰個。Here we have two repeated patterns, 1 and 2. So the total distance for it should be 2 lambda. How about the total time? The total time should be 2 period t, and then 2 and we will cancel it. This one equal to the speed of this wave. Keep the same, no change. Even we increase the lambda, even we increase the period t。呢個幾高深嘅嘢，聽住咯。如果我將個 period 升高，咁即係大家要完成一個 cycle 所需嘅時間長啲嘅話，咁點咧？你發覺啦，既然時間長啲，咁佢個 lambda 咪要再長啲咯。咁所以兩個做完除數之後咧， 背後速度都係不變嘅。咁之前講過啦，速度係冇可能變嘅，即使你揈大力啲，你只係改變咗個 frequency， 但係你改變唔到個速度。記住啲嘢。So here, suppose a wave of a frequency 2 Hz and lambda is 3 meter. What is the period? Now you can see that this period and frequency should be closely related. And what is 2? In symbol, you should write it down. F is 2. But what is period? Should be 1 over t. Then that's all. Then you can see that t should be 1 over 2. Like that. How about the wave speed? It means that v. You can remember the formula should be F lambda. Okay, what is the lambda? I know it. 3. Okay, here. Lambda is 3. How about the frequency? 2. And that's all. The answer should be 6. This one will be examination part B question. Not very difficult one. Okay, the other one. Factors affect wave speed. Lastly, I mentioned that V will not be changed. Yes, if you just only change that frequency and lambda, there's no change. But if you change the medium, it will be changed. 改變 medium 佢嘅速度一定唔同。點改變啊 ？Here depends on the properties of the medium。你個 medium 係一啲 string 啊、water 啊定 solid 咧係有唔同嘅。Independent of amplitude and frequency， 呢個咧喺 MC 裏邊好緊要，成日陰你嘅 frequency 高咗，速度係咪高咗？不是，記住 frequency 高咗咧個速度都係唔變嘅，係 lambda 下降嘅啫，記住。好，this one tells you that what is the factor of it? Denser string， 咦個 string 密度高啲喎，多啲物料喎。inertia 大啲喎，喐你嘅能力渣啲喎，咁咪行得慢啲咯，幾合理。學完 mechanics 就有啲咁嘅情況啦。好 ，next one larger tension， 咦扯痕啲喎，扯痕啲即係話 particle 與 particle 之間嘅距離遠咗喎，咁但係又黐住嘅喎，咁點啊？當我傳能量嘅時候 ，under 咁大嘅 tension 嘅時候，咁咪傳得快啲咯，所以 travel faster。嗱呢個唔做實驗咧，你就唔信噶啦。做完實驗之後咧，你就冇可能信啦。咁所以留翻嚟做實驗啦。好 ，next one 嗱呢個要背咗佢。咁但係其實喺下一課咧 ，water wave 裏邊咧會再講多次嘅。咁嗰陣時我又會提你咧，叫你背咗佢。Shallower zone travel slower， 淺水嘅地方行慢啲嘅啲 wave， 所以大家近岸嘅時候，你見到啲 wave 咧就行慢啲嘅。邊度行快啲啊？深海、公海就行得快啲噶啦。OK， 咁點解咧？作假嘅方法先解得。咁到時做實驗嗰陣時又話翻俾你聽。So finally, we get this wave equation. And one more English word, power， 緊啊，拉緊嘅意思啊。Power 緊再緊啲。OK， then what will happen? The speed will be increased. Okay. Now try to look at example 1. Now, example 1, what is it? We will have an original transverse wave at time t is 0. But after a certain time, the wave will travel to the right-hand side like that. But actually, this right-hand side will with a small distance, x, like this. Now, part A. What is the period and frequency of the wave? How to know that? Go back to the question. Will be this one. Very important part. This time. It means that from the wave, from here, the crest, to the new crest, the time for it should be 0.02 seconds. But how about the displacement? The distance traveled will be x. Here, we want to find out the period. How to know that? This one. The wave travels 1/6 wavelength after 1/6 period. This one, very important concept. Go back to here. Can you see that? The line, okay? starting from this position. You can see that 1, 2, 3, 4, 5, and 6. Then it go back to here. You can see that this one is the repeated pattern. Okay, 6 wave. And at the same time, you can see that this one, travel x. Okay, distance is x. Yeah. What's the lambda? Lambda should be 6x. Can you see it? Lambda should be 6x. How about the time? The time should be, this one should be 1 cycle. But look at this. The time for it should be 1/6. Okay? Finally, you can see that travel 1/6 wavelength. The time is 1/6 period. Okay, combine these two together, you can see that the period should be 0.06 because the time given from the diagram should be 0.01 second. Okay. How about the frequency? Very easy. Pick out the equation, then you can get this one. And Puppy, suppose x is 6. It means that gives you the exact value. Estimate the speed on it. Now look at this. The speed should be 6 cm for 1 cycle. Okay, no, x is 6 cm. It's not 1 cycle. Because the question gives you x 6 cm. But how about the time? The time should be, we need to have this time 0.01 second for it. After the calculation, the speed should be 6 meters per second. How about the wavelength? You can pick out the equation, the wave equation. We know that V is answer. We know that the period is answer. After the calculation, you can find this. Okay, question number 2. This one should be related to the longitude wave. And also look at the question from left to right. It means that the travel direction should be this. And the figure shows the displacement of the particle A to M in the medium time t. Okay, this one should be equilibrium position. After a certain time, will be like this. And also given to you frequency is 5 Hz. Now, when you look at this, what should you do? You should try to find out the compression center and rarefaction center. How to know that? The compression center must be equilibrium position.嗱，記住，我頭先冇講，而家再講。Compression center 好慘嘅，被人壓迫得最慘，壓到佢根本喐唔到，所以冇喐。咁啊，但係佢隔離啲街坊好中意佢，就逼死佢。咁啊，所以發覺 B、C、D 特登走埋去逼死佢嘅。阿 E 有冇啊？有，不過唔夠遠。阿 F 有冇啊？都有，唔夠遠。不過有個人亦都係咧，佢冇喐過嘅，佢今次就唔係俾人逼走，係俾人放棄。咁可能佢臭啦嚇，咁所以 F 同 H 都唔中意佢離開。咁因此呢個咧，你 identify 到呢個叫做 R rarefaction center, A compression center, M compression center. If you know that this, then that's all. Because you can see that the wavelength should be from here to here. How many cm? Count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For each one, 10 cm. So your answer should be 12, 10 cm, 120 cm. Okay? We know that lambda. We know that frequency. We can know that the velocity. It means that the speed. Okay? So here, at time t1, which particle are the center of the compression and rarefaction center? I showed you already. Is part B. Part A, okay? Part B. What are the amplitude and the wavelength? Amplitude will be hardest one. 呢個 最難嘅喺 Longitude Wave 裏邊，因為點解啊？你唔應該睇 AGM， 原因因為佢哋好似冇喐，一個就逼到冇得喐 AM， 一個就係啲人唔中意佢，所以唔喐就係 G。咁邊個喐得最勁咧？自己睇清楚。但咩叫最勁啊？睇佢原本嘅位置，原本嘅位置係呢啲，呢啲係原本嘅位置。邊度最新位置啊？我求其拿個 D 嚟睇 ，D 最新位置喺呢度。佢原本位置係咩啊？唔係呢度，呢個位不是，係呢個位。而家咪依企緊咯，唔係，而家講緊 D。所以咧，當你 measure 阿 D 嘅 displacement 咧，應該係阿 D 嘅 equilibrium measure 過去呢度。呢個就係難嘅地方啦。你都覺得淺嘅咧，恭喜你啦，真係淺啦，明唔明？10題有得1題係佢，因為驚啲學生解決唔到我啱啱講嘅嘢，係 refer to is equilibrium position。個 is 咧，你而家揾 D 就係 D， 你揾 E 咧 ，E 啊嚇 ，E 就係應該 refer to 呢個。所以咧，好快咁答翻嚟 ，E 嘅 displacement 係咩啊？睇你分前定後係正。如果我話俾你向呢邊叫正，咁啊 E 嘅 displacement 將會係負5個細格仔，即係負10 cm。咁係咪最勁啊？睇下 D 咯，阿 D 係褪後咗幾多格啊？7個細格仔，每個細格仔係2，咁所以佢應該負14。咁佢係咪最勁啊？唔知，再問阿 C 啦。阿 C 都係褪後，不過5個細格仔，即係10 cm。咁所以啦，唔使諗啦，阿 D 咧將會喐得最勁。咁而最勁嗰個地方係咩啊？就會叫做 Amplitude，即係答案係14 cm， 唔使理正負。咁至於啦，個 Wavelength 幾多啊 ？Wavelength 我哋應該計個 C 與 C 之間嘅距離，頭先計咗啦，120，得唔得？120 cm 嚇，即係1.2米同埋0.14米，得唔得？嗱，你如果D 一個都 OK 嘅咧，咁冇嘢難到你噶啦，暫時嚇。OK，Part C，if we increase the frequency to pay attention on the English to not by 唔知幾多，總之去到20。What are the wave speed and the wavelength now？ 咁就係嗰句咯 ，speed 係唔會改嘅，即使 frequency 喐咗 ，frequency 喐咗咁點啊 ，lambda 咪喐咯。So based on this equation, we know that the speed cannot be changed, but now frequency have been changed. Then lambda should be changed. Okay, so new lambda should be original speed and then new frequency. Finally, you can get this one. I'll go back to here. To 20 hertz. How about the original one? Original one should be 5. From 5 hertz to 20. Frequency is starting from 5 to 20. Increase 4 times. Okay? But based on the wave equation, we have this one. V is F lambda. V no change. But now frequency increase 4 times. Lambda should be reduced 4 times. Final answer, you can see that original should be 1.2 meter, reduced 5 times, should be 0.3 meter. This one is the MC skills to answer the question. Okay, any question? Okay, that's all for this example. Last one, chapter 3, only 2 questions. Then we will complete chapter 13.3. Okay, look at this. OK， 嗱，我講得太多啦，揾下大家問下問題。等陣先啊，而家係幾點咧？我哋去到4點啊，仲有9分鐘，係正啦，完埋佢就完啦。OK，look at this。一陣間我順便點埋名 ，OK。咁其實個系統點緊名嘅，咁一陣間咧就問問題點名啦。咁我哋暫時咧就唔用個網上系統嘅，下堂先開始 ，OK。咁因為啲人名咧未 set 翻好啊。 好嚟，跟住我問你，一係就開咪答我，一係咧就係 chat point 答我。咁我第二部電腦睇緊大家個情況嘅。OK 嚟咯。Two waves are produced in 0.2 seconds, and wavelength is so like this. Okay. What is the wave speed? Now, in this question, I will divide this question into several parts and then ask you question. Okay, so pay attention. What is the question? Okay, now here, two waves are produced in 0.2 seconds. Then, how about the time? Time for one wave. What is it? Okay, okay. 好，睇啦，睇下先，我執下啲人啲樣先啊。等一等。好啦，得未？好，咁而家揾人答咯喎。咁啊，你可以喺個chat room 裏邊答我啦，或者開咪答我都得。咁啊，求其啦，好冇？睇下先啊。譚文斌先嚟。譚文斌 ，time for one wave. What is the answer?
Time for one wave
係
係0.8 amp per second。
零點幾？
0.8。
0.8。錯。錯。俾多次機會你。Two waves are produced in 0.2 seconds.
係0.1。
係啦，0.1。點解你睇到0.8嘅？
因為我信咗錯名咯。
啊？信咗其他人講咩啊？點解啊？啊？點解有咩問題啊？
受上天感召。
唔係啊！嗱，記住喎，唔好錯啲咁嘅嘢。講到明就係兩個 wave 就用咗0.2秒，咁一個 wave 梗係用翻 mass 嗰啲 proportion 嘅關係啦，除2 ，OK？ 咁所以啦，0.1 ，OK？ 好，繼續，我將條問題分解咗好多 part 㗎，其他人又注意咯喎。嗱，通常咧，我哋仲有幾分鐘啦嚇，就唔會再問你㗎啦，所以譚文斌你可以唔使答其他嘢啦。好，另外一位睇下先啊，黎樂賢啦，
係你好。
好，你好，非常之好啊，你反應非常之快啦。嗱，今年俾心機咯嚇。好，答我，好簡單問題。Time for one wave， 一個 wave 要用幾耐時間完成？呢個嘢有個特別嘅 term 叫咩名
？Wavelength 係嘛？唔知。
喂，你唔好老吹先，諗清楚，特別嘅 term 叫咩
？frequency 啊。
frequency。
哇，邊個陰佢？
音我衰仔。
咩㗎？一個 wave 要完成嘅時間叫咩名？嗱 ，frequency 有人提你 frequency 啦 ，frequency 中文叫咩啊？
我唔知係咪 period 啊？唔知喎，求其啦。
frequency 叫頻率啊嘛，頻率就話1秒鐘可以做幾多次？
係啊。
咁而家呢個係咪1秒鐘做幾多次？
唔係啊。
唔係，咁呢個係講俾你聽，一個要用幾耐時間，因此英文叫咩？係英文叫咩啊？
係咪 period 啊？
係啦，符號咧？
好嘢。
符號個符號叫係咩啊？個 symbol
係咪大階 T 啊？
係大階 T。
大階 T， 哇哦！
得唔得？嗱，記住咯喎，嗱，記住 wave 咧，主要係學啲 terms，你有清晰地理解就唔會錯噶啦。得啊嗬？好，跟住下一位同學難少少啦，真係唔知係咪難少少定好難啦嚇。好，下一位睇下先啊，邊個咧？陳德康咧？陳德康開咪定打字？ 反應。一係你喺 chat box 裏邊打嘢，一係就開咪。俾多次機會你，陳德康。係陳德康啊，係咪啊？等陣先啊，等我整啲大家合家歡嘅樣先。好，陳德康問問題 ，ready 未？得啦嗬 ，OK。好，得陳德康。呢個難少少啦。我係順序落去嘅嚇，難少少。我想問你咧，而家你喺呢個問題裏邊，幅圖裏邊咧，完成咗幾多個 cycle 咧？2個，得中。中啦嚇 ，OK。中，你搞掂啦，難少少啦。好，答完，中㗎你啊。好，而家喺幅圖裏邊有2個 complete 嘅 cycle。好，下一位。林良希。咁你答問我喎。好，嚟林良希。呢度就頭先同學就答咗啦，有2個 complete 嘅 cycle。我想問啦，一個 complete 嘅 cycle 有幾長咧
16 cm。
16 cm 中。好，下一位同學，你應該估到我問你咩㗎啦？頭先係16 cm 啊。好，下一位同學就頭先叫你收聲嗰位同學安志康。安志康，開咪。
喂，早晨啊！
早咩晨啦，午安啊！你阻住我食下午茶啊。OK， 好，安志康。呢度
好啊，
頭先同學咧就係話啦，一個 complete cycle 就係有16 cm。咁你估唔估到我將會問你咩問題咧？
我估你會問我食咗飯未咯？
冇咁廢嘅。應該問你下午茶添啊！除咗呢條問題之外咧，
所以你想問咩啊？
點啊？
唔知喎，我好蠢。
唔知喎，咁我就問你啦，16 cm 即係咩嚟啊
？16 cm 即係佢佢一個 period 可以行到嘅。
係啊，叫咩名啊？最緊要
嗰個咩啊？嗰個咩啊？
重點
嗰
叫咩名？
嗰個入啊嘛，我識入啊嘛，唔知點讀㗎啦，唔記得咗啦。
英文咧？
單坦啊？
讀音就叫 Lambda。英文叫咩 ？Wave。
唔知喎，
喂，好緊要，好緊要 ，wave 乜嘢
？Wavelength。
係啦 ，wavelength 啊，記住。因為咧佢 part A 嗰啲問題就問你 what is this keyword 嚟㗎嚇，頭先我啱啱問晒所有嘅人都係嗰啲 keyword 嚟㗎。咁而個 wavelength 咧就係16 cm。好，下一位同學，下一位同學咧就係潘明彤啦。喂，潘明彤喺咪度？有冇咪啊？
潘明彤仲有讀嘅咩？
咩？仲有讀？
唔係，
佢唔係 drop 咗科啦咩
？drop 咗科？冇啊，個 list 裏邊仲有佢嘅喎。
咦？佢一入嚟嘅時候退咗，佢一直都唔喺度喎。
係咩？
你一開始入咗嚟一陣，
佢冇啊，佢走咗。
點樣系統計緊每刻嘅？我冇
講鬼喎！
你計咗佢，但係計完佢之後佢走咗，可能係。
唔係㗎，個系統係每時每刻都計緊嘅，咁知道佢幾時走添。OK。
好勁啊個系統。
得唔得？好，咁啊，下一位啦嚇。因為我係要完咗先睇翻。好，咁下一個啦。咁佢答唔到咧，就下一位。下一位係咩啊？黃可穎咧。黃可穎喺咪度？
喂，可穎出嚟啊！可穎。何穎啊，人哋叫。
黃可穎啊。
係啊。
唔係何穎嘅咩？
黃何穎啊。
佢打邊爐得閒佢。
何穎喺咪度啊？打字。OK， 好，打字答。死啦！噏完咁大餐嘢，唔記得想問咩問題添。係啦，問啦。佢問你咧，就 What is the wave speed？ 咁嗱，等陣先啊，好似用文字答就幾難答喎。OK， 好啦，算我放過你啊。呢個俾啲人開到咪嗰啲答啦嚇，因為打字都有答。好，尾3位嗰位同學張順謙喺咪度？ 張信謙，
係
好揾你用聲音
做啊
回答啦啊，唔忙啊。好 ，What is the wave speed？一見到呢條題目腦裏邊諗咩？
16 meter per second。
係你又係答案嚟嘅，我要街住其他同學，你應該心裏邊第一時間諗咩 equation？
phi 等於 lambda over period。
哇！呢、個 over 嗰個我唔識嘅，我識打橫過冇 over 嗰條 v 等於
咁鬼死多要求嘅。
係啊 v 等於
frequency。我考試寫頭先嗰個問題啊嘛。
任你啦，冇所謂嘅。但係考試佢俾你嗰條咧，就係 v 等於 f lambda 嗱，咁記得喎，同學，呢、個叫做 lambda v 等於 f lambda。咁你心裏邊要諗呢、個 frequency 記得而家
over 0.2。
係錯嘅，
1 over 0.2。
係啊，係錯噶，係1 over 0點幾。你望下 screen 啦，有嘅。
我0.15。
係啦，0.1。
因為我計咗咩啊？
係。咁 lambda 幾多？
lambda 我用咗兩個方法。
嗱，你真係慘啊！其實我呢度咧就問晒頭先嘅同學所有嘅答案就堆砌喺度嘅。lambda 幾多
？lambda 係16
cm 係錯嘅。
cm。我翻嚟0.16。
係啦，啱啦。OK， 明唔明？咁你要自我反省啊，咁樣乘埋就係答案啦。
但係如果我個 lambda 寫咗0.32，我 t 寫咗0.2得唔得？
完全得。
OK，
因為你計咗個 total 嗰個關係。咁但係咧，如果你用嗰個方法咧，係冇用到個 wave equation 嘅，你反而就用咗咧中四所學嘅 total distance 除 total time。驚唔驚到？
咁得唔得咧？
但係你話得唔得啊？
得啊。
得咯，梗係得啦，梗係得啦。
咁點解唔係我簡單啲？
唔係喎，因為我哋 long term 嚟講咧，長遠嚟講，我哋用緊呢條式嘅喎。OK， 得唔得？好，咁所以啦，答案咧就係1.6 meter per second， 有冇問題？好，咁我哋要快落堂啦，因為而家超咗4分鐘。好，答埋呢幾條問題就完啦，仲有3條問題，咁仲有3位同學要答問題，嚟咯噃。佢話啦 ，two students shake two long springs A and B made of the same material。嗱，記住呢個最緊要嘅字係 same material。Same length， 即係乜都一樣，只係爭咗兩個人喺度揈嘅啫。Suppose the wave travel faster along A。又話同一樣嘢，點解會有速度唔同啊？就係頭先咧，其中一個 slide 就係話我哋點樣改變速度。OK， 得唔得？咁我就揾3個高人去答啦，嚟咯。咁就我哋個班裏邊嘅第一位嘅同學。你應該知邊個啦？上年又係你第一位嚟㗎嚇，就係 H 班嘅18號啊。阿鄧俊欣喺咪度？有冇咪？
喺度。
係喺度。好嗱，你咯喎。如果我將條橡筋繩拉長啲，你覺得佢嗰個速度行快定行慢？
行慢。
行慢。OK。你中咧係錯嘅，拉痕啲咧係行快啲㗎嚇，記住咯喎，錯一生人錯啲次好啦嚇，以後唔好再錯咯。好，仲繼續答，咁 A 嘅答案係咩咧？Possible or not？ 佢一講呢個情況俾你聽咧 ，A 係行快過 B 嘅，跟住有人就話俾你聽啦 ，A 咧。點解快啲啊？因為佢揈個 frequency 高啲。
possible
定錯
possible 係咪？
即係你答 possible 係咪啊？
係。
好，答案係 impossible。嗱，記住喎，今日最緊要 get 到嘅嘢咧，就係頭先嗰條問題，就係大家知道咩叫 period 啊、frequency 啊咁嗰抽嘢啦。除此之外咧，你要知道 speed 啊。wave 嘅 speed 咧點樣改變咧？點樣先可以改到咧？而家改咗噶啦，就行快咗。改變個方法咧 用 frequency 嘅方法改變係不能嘅。原因點解咧？因為背後有條咁嘅式。速度如果根據翻呢條式嘅話咧，係唔可以改。你改 frequency 咧，你只可以壓低個 lambda， 即係個 wavelength。你將個 lambda 拉長啲 ，frequency 只會下降，永遠個 v 都唔變。點樣先可以將個速度改變咧？
咁一個 v 唔會變啊！我將個 frequency 又拉長，
點解個 v 唔變咧？就因為處於一個相同環境之下咧，全部嘢定好晒啦。咁呢個相同環境下咧，就係 same material 啦、same length 啦，同埋 same BC part 啦。未講，陣間講埋。總之嗰啲嘢全部都冇話俾你聽改咧，佢就永世唔改噶啦。即使你改變 frequency 都好，都唔會改。咁至於有啲咩方法可以令到佢行快啲咧？咁其實我頭先已經問咗佢咧，阿俊欣咧問咗佢啦，拉長拉佢緊啲嘅時候會點啦？咁啊會唔會 BC part 就問嘅呢個問題咧？而家睇唔係拉緊啲喎 ，A is lighter than B。lighter 點解？問下一位同學，下一位同學咧答嘅問題咧就唔係答 physics 咯，就答英文咯嚇。李耀祖啊，李耀祖，開聲定好？李耀祖 lighter 點解英文
？mass 低啲咯。
係啊，個 mass 低啲，即係個密度低啲。咁你覺得如果密度高啲，你揈佢嘅時候容易定難啲咧？
難啲啊！
難啲。咁如果輕啲咧？
咪快啲咯。
咁咪快啲。咁你覺得 Part B 嘅答案係 possible 定 impossible 咧
？possible。
咁咪 possible 咯，得唔得？所以大家係可以用翻你中四學過嘅 mechanics 咧，係答到以上嘅問題嘅，因為係 close related 嘅。所以啦，如果你揈嗰條大纜係又粗又重嘅話咧，好難揈，啲 energy 好難 transfer， 斷估都唔會行得快去得去邊。OK， 得唔得？好，第三 part 啦 ，C 啦，最後一條問題啦。The tension along A is larger， 即係拉 A 嗰個嘅 tension 比較拉得痕啲嘅，咁會唔會就令到佢行快啲咧？下一位同學就係終結者啦，睇下先嚇。睇下先邊位好咧？好，阿蔣卓南啦，蔣卓南係好。點啊 ？Possible or impossible？Possible。中啊！嗱，所以啦，最後尾 summary 咯，最緊要嘅今日嘅 summary 啦。我哋要點樣先可以將個 wave 嘅速度改變啦？例如增加佢嘅速度，咁啊其實得兩個方法嘅啫。一個方法就係將個 tension 增加定下降啊。係喎，冇問邊個嗬？安志康啦，又再答個。安志康，你幫手做 summary。
又係我啊，好啊，你好啊，我翻嚟啦，係。
好，咁啊做下妹啦。我想問速度要增加 ，tension 要點
？tension 梗係要大啲啦。
要大啲啦嚇 ，OK。咁啊另外一個密度嘅符號叫做 wow 9。咁啊我寫得差，應該係條尾咁樣兜一兜，咁即係佢叫 wow，OK，wow 啊嚇，希臘字母。呢個就代表 density。咁 density 高定低啊？如果想
低好啲啦，
梗係低好啲啦。咁低點擺啊？就係最好擺分母咁樣嘅。咁有條歐斯嘅式嘅係咁樣嘅，開方 tension 除 wow， 咁就係速度。咁啊曾經咧公開考試出過，但係你唔需要去識，就係噏咗啲嘢問你個關係嘅啫。咁你都會知道啦。呢個要下降 ，tension 上升，咁速度就會行快啲啦。除此之外，改變 F 得唔得啊？安志康，
改變 F
係，
你可以試下嘅。
我問你，
不過時間就唔太多啦，你可以下次先試。
係嗱 frequency 咧，你改變咧係改變唔到個速度嘅。Lambda 改變得唔得啊？
應該得啩？
梗係唔得啦，冇唔得㗎，記住啊，呢個 summary 嚟㗎嘛，所以話俾自己聽， 只係改變 tension 同埋個密度先可以令到個速度增加嘅啫，其他嗰嘢都改變唔到嘅。
係好
係啦，
啊，好
有冇問
啊，
題？
冇啊，
嗱冇啦，冇啊，咁啊同過往一樣，咁我哋都收檔㗎啦。唔該喺個 chat box 裏邊咧打翻個 buy。